Alright class, so in our last video we did notice that the angiotensin 2 works on the supraoptic nucleus and causes release of ADH from the posterior pituitary, which then acts on the collecting duct, and the collecting duct in turn retain more water in our system, so we pee less and we have more water in the system. That increases the blood volume, increases the end diastolic volume, which eventually increases stroke volume, cardiac output, and ultimately increases blood pressure. Okay, the angiotensin 2 also works on the adrenal cortex. So let's take a look. The angiotensin 2 comes all the way and works on the adrenal cortex and causes the adrenal cortex to release a hormone called aldosterone. Very, very important hormone, aldosterone. Aldosterone works on the distal convoluted tubule of the kidney. So aldosterone will work on the kidney. Specifically, it'll work on the distal convoluted tubule. And aldosterone causes the kidney to retain salt. So this will cause the kidney, in turn, will retain sodium. And as sodium is picked up, what follows? Water. So I want you to understand this. ADH works on the collecting duct and only helps to retain water. Aldosterone works on the distal convoluted tubule and helps the kidney to retain sodium and water. So there is difference. Aldosterone is not the same as ADH functionally. So as you have more sodium being reabsorbed in the body, what happens to blood volume? That leads to increased blood volume, more blood volume. That leads to ultimately leads to increased blood pressure. Okay, so this is another compensatory way or another compensatory mechanism for increasing blood pressure. Now, okay, angiotensin 2 also works on blood vessels. Let's take a look. Okay, so this angiotensin 2 also works on blood vessels. Actually, I'll just draw like this. And it specifically works on tunica media and causes contraction, causes vasoconstriction. If there is vasoconstriction, what happens to the blood volume ultimately? Well, vasoconstriction will lead to increased blood pressure. So these are the three compensatory ways. So we just looked at this one, right? This is number 1. This is our number 2. And this is our number 3. Okay, let's do a super quick review. So the problem is we have low blood pressure, right? The low blood pressure is sensed by specific kidney cells called juxtaglomerular cells or JG cells. And in return, the JG cells release a hormone called renin into blood. Renin travels via blood and reaches the liver. In the liver, there is a protein called Angiotensinogen. Renin activates angiotensinogen to angiotensin 1. So now we have angiotensin 1 being released out of the liver into the bloodstream. Angiotensin 1 floats in blood and then moves, or the angiotensin 1 reaches the lungs. In the lungs, there is a specific enzyme called angiotensin converting enzyme, or ACE, which works on angiotensin 1 and converts it to angiotensin 2. Bam! This is what we were looking for. We need angiotensin 2. Angiotensin 2 has 3 targets. It works on the hypothalamus, it works on the adrenal cortex, and it also works on the blood vessels. So let's take a look. Angiotensin 2 first works on the hypothalamus, specifically the supraoptic nucleus, and that causes the posterior pituitary to release antidiuretic hormone. The antidiuretic hormone, or ADH, specifically works on the collecting ducts of the nephrons and causes water retention in the body. As we retain more water in the body and we excrete less urine, that will obviously help to increase blood volume, which in turn increases end-diastolic volume, which in turn increases stroke volume and cardiac output, resulting in increased blood pressure. So this is the first compensatory mechanism we looked at when talking about the renal compensation. Secondly, angiotensin 2 will work on the adrenal cortex, as shown by the black arrow here. This is the second pathway. It works on the adrenal cortex and causes the adrenal cortex to release a hormone called aldosterone. Remember, aldosterone is a mineralocorticoid. Aldosterone specifically works on the distal convoluted tubule, or DCT, and causes retention of sodium. So sodium leaves the tubular fluid and enters the bloodstream. And remember, sodium is always followed by water. So as sodium is reabsorbed back into the bloodstream, water follows. So we have like sodium water or salt water coming back into the body, and that helps to increase blood volume and blood pressure. Thirdly, the angiotensinogen 2 works on blood vessels, as shown here. I'll just highlight this, like angiotensin 2 works on blood vessel. I've also drawn like this arrow here. So angiotensin 2 works on blood vessels, specifically tunica media, which results in vasoconstriction, and vasoconstriction of blood vessels help to increase blood pressure. So we are done with the renal compensation for hypotension. In another video, I'll talk about the compensation for hypertension, and I'll post that tomorrow because I'm super busy today. Thank you.